Now we are discuss about port roles in STP. Port roles. Basically in STP there are three major port roles. The first one is root port. The second one is designated port. And the third one is non-designated port. Now we will discuss about root port. After electing root bridge, every other non-root bridges select a port as a root port. The root port is the link with the lowest path cost to the root bridge. If more than one link is connected to the root bridge, then a port cost is found by checking the bandwidth of each link. Basically, if the scenario is like this is switch A, this is switch B, and this is switch C, then for example, this switch becomes root bridge. So every other non-root bridges like B and C for this scenario elect a port on itself as a root port. Root port is a port that is have a lowest cost or the best path to reach root bridge. For example, in the perspective of C, this is the lowest cost. This link has the lowest cost to reach this root bridge. So this port called as root port. For B, this port is called as root port. The port that have least cost or best path to reach root bridge is called root port. The second one is designated port. It also in forwarding ports It is also forwarding ports just like root port, but they help forwarding the data downstream towards the non-root bridge. It means these are the ports that helps the root port to send data to non-root bridges. This is root bridge, for example. These are non-root bridges, so the port that helps root bridge to send data to non-root bridge is called designated port. Each link segment have one designated port. For example, in this case, this and this, three links are there. Every link have at least or at most one DP compulsory. The third one is non-designated port. Non-designated port is one with the highest cost than the designated port. These are basically the one left over after the root ports and designated ports have been determined. Non-designated ports are put in blocking or discarding mode. They are also called block ports. Now, how the bridge elect the root ports and designated ports. The first one is root port. Now we are checking the process how the STP elect the root port. For example, this is our scenario. This is our root bridge. These are bridge number BR and this is bridge C. Root bridge, as I already mentioned, root port is a port by which we can connect root, and this port have least cost to reach root bridge. It means root port does not have any root port. Root bridge does not have any root port. But all other non-root bridges have compulsorily a root port to reach the root bridge. It means in this case, this switch does not have any root port because this is root bridge. But all other bridges have compulsorily one root port. For selecting the root port, there are election on every non-root bridge. The criteria for selection the root port is, the first thing is least port priority. In case of STP, switch also have a priority and port also have a priority. Switch in Cisco switches, switch have 32,768 by default priority and port have a by default priority 128. You can change priority from 0 to 255. A port that have least port priority becomes root port. But if the all ports have equal priority, then the decision comes to lowest cost. As we already discussed about cost, like if the link is 10 Mbps, then the cost is 100. That is Ethernet links. If the link is 100 Mbps, then the cost is 19. If the link is 1 Gbps, the link cost is 4. And the link is 10 Gbps, then the cost is 2. This is fast Ethernet links. These are the gigabyte Ethernet links, and these are 10 gigs or 10 gigabyte Ethernet links. If the all links have same cost, then the election comes to lowest bridge ID. If the bridge ID also same, then the election becomes lowest port ID. Here the port ID is the port connected to the lowest port number on the upstream switch will be the one that used. For example, if the scenario is like this is switch A, this is switch B, this is our root bridge, then the first thing to check for root port is least least port priority. The port priority for both ports is equal, then the election comes to the lowest cost. This link also have cost 19. This link also have cost 19. Then the election comes lowest bridge ID. For this port and for this port, the port ID is same because these two ports are belongs to same bridge. Then the election becomes the smallest port ID. In the perspective of B, the port ID is checked for the upstream router. For example, this is a FA0 by 1 and this is FA0 by 2. Then we select this port as a root port because the upstream router's port is have the lowest port ID. By this way, every non-root bridge elect the root port. Here the point to notice is the root bridge can never have a root port, and every other switch in a network, every other switch means every non-root bridge. Every non-root bridge in a network must have one and only root port. It means every root port in every network, root bridge does not have any root port, and every non-root bridge compulsorily have one and only one root port. For electing the root port, we have these criteria that we already discussed about. Root port is always in forwarding state. Root port always forward the packet to non-root bridges. After electing the root port on every non-root bridges, switch or STP start to elect designated ports that are DP. DP or these ports also in forwarding state, but these forwarding states are to the upstream routers, that is root bridge. In the network, every single or every link have one designated port. Let's take an example like this. This is our switch A, this is our switch B, this is our switch C. They are connected with this like this. It means this is root bridge. These are non-root bridges. It means this bridge or this switch does not have any root port. These two switches compulsorily have only one root port. Every link for this link, for this link, and for this link, every link have one DP compulsorily, that is designated port. Every link have one designated port in the scenario.